All right. Well, welcome everybody. What a day, day three. Goodness gracious. The World Series just wrapped up. We've got Halloween and now this amazing keynote by Christina Fillmore at GSK, data science leader. She does amazing work in the space, really, really awesome work, whether it's from packages like Metacore, MetaTools, T format, or working on things like Beast. You can track a lot of these and see these packages on the GSK GitHub and also on her GitHub, which is amazing. Statusaurus, love the name. She also does a ton of awesome support in the community, helping things like R and Pharma, open source in Pharma, and another group that definitely people should know about, which is called Camus. And it's about evaluating the statistical results of both R, Python, and SAS. So take a look at that if you haven't seen it. She also does amazing workshops, whether it's at Posit Conference or at the R and Pharma Conference. I always love to attend them and take a look at it. So I can't think of anybody better to talk about the intersection of AI and data science and pharma than Christina. So with that, I will pass it over to her for the keynote for day three.
Okay, thank you, Harvey. Thank you, Phil. I've been talking to Harvey a bunch because I've been trying to be organized about things, and thus I nearly called you Harvey. Um, Hello, everyone. Happy Halloween. Hi, my name is Christina Fillmore, as Phil said, and I am going to talk to you today a little bit about accelerating GSK's open source journey with Gen AI. Strike clicking the right thing. So first of all, large language models, you probably have heard them. You've probably heard a lot about them. They kind of came onto the scene in late November of 2022, and that's when they really started to pick up steam in terms of uses and all sorts. So we quickly, after they kind of OpenAI rolled out their ChatGPT system, you started to see headlines like ChatGPT that sets the fastest record for growing user base, or things like, oh, ChatGPT is going to replace our jobs. And as someone who's been working kind of in this space for the past 2 years, I can tell you both that ChatGPT has not replaced my job, but also that I still can be able to use it. So here I'm going to be able to I'm going to talk to you a little bit about today about GSK's kind of the biostats organization's journey with LLMs kind of from today through to tomorrow. So a little bit to talking about how GSK has adopted to this new technology, and what experiences we've had, and with that, and kind of what experiments we've been doing and how we've been thinking about adopting this technology for solutions for tomorrow. And really what we want to do today is to just share our experiences and what knowledge we've gained along the way. So first of all, let's start with today. When we're talking about today, I'm talking about the things of getting getting these kind of LLMs and this technology into people's hands as soon as possible. So how did we do this? The first thing we did is that our data science teams, so here in the biostats organization at GSK, we have a specific data science team, and we started to look into the number of ways you could directly use LLMs, from email to code generation, and specifically around learning new programming languages. Because at GSK, like at many pharma companies, we're in the midst of this kind of transition from historically using older proprietary languages into using these open source languages, which means we have a pretty broad community who needs support and help converting over their historic skills in these proprietary languages into things like R. So we knew that we wanted to do this, and we had some kind of ideas of how this would work, but we didn't really have a place that we felt comfortable recommending to people that they could definitely just go, feel free to use this. You don't have to worry too much about it. And that's where our wonderful AI/ML team at GSK comes in. So they brought in an internalized version of the GPT model for us and created a kind of front end that allows people at GSK to use and leverage the power of GPT and large language models generally, while staying safe in a GSK walled garden, and so that we don't have to be so careful about data security and things like that. So that's been really great for us. And so this really was the first step to allowing this broader community basis. So once we got it in-house, it was now time for a rollout. So we had a lot of things to consider when we were thinking about how do we roll this out to our audiences. And we really came to the conclusion that it didn't feel right to necessarily run a formal training as you typically would, and as we've done in the past for things like learning R, because you probably didn't do a class at school of learn how to Google things. It's one of those things that you've just picked up on, like, as a life skill, using Google more and more until you've gotten better at it. So we've had to think, how do we want to get this into people's hands? And we figured one of the best things we could do was focus on creating some guides to provide relevant examples of how people might want to be using this stuff, as well as just other information about LLMs and that sort of thing, and kind of skills in terms of if you want to do some prompting improvement, here are some ideas of how to improve your prompting. And so we created these guides, and then we started to present in small groups, allowing people the flexibility and freedom to ask questions and interact with us a lot as we were presenting. And the result of this was that we had some of the highest adoption rates across GSK in biostatistics. Biostatistics has been an early and kind of consistent adopter of this new technology, which has been really great to see. So once we got the kind of today situation set up, today people are using LLMs at GSK in biostatistics pretty regularly, but more through the kind of chat-based system you would expect. We started to think about tomorrow. So looking into tomorrow, we had to figure out, where did we want to start with LLMs and what kind of automation do we hope to see? So we started with thinking, we went to the chatbots just like everyone else and said, "Hey, can you make us an Atom set data sets? Sorry, can you make an Atom data set? Can you make like an ADAE?" And we started playing around with asking for various CDISC data sets. Now, then let me take a second to explain some of the jargon I just used. So CDISC, for those of you who don't know, is the kind of centralized data standard that we use in pharma in terms of how we expect our data sets to go to the FDA. So the FDA only expects them that way, and they come out in a series of data sets, and each data set is a particular domain. So for the example I'm talking about here is ADAE, which is basically the domain that contains all of your adverse event information. And so here, we've asked it to make ADAE, and I know the text is a little bit small, but it did do some things right. It made a U subj ID and it made an ADD code. Those are both things that exist in an ADAE dataset. Unfortunately, how it made it doesn't make any sort of sense. So what we found out was that these LLMs kind of understood CDISC terminology and could definitely parrot back pieces of CDISC terminology back at us, but it didn't really understand in a true sense of what the variables should be and how they should come through. So we were like, okay, this feels like it has some promise, but it definitely doesn't understand enough to be able to go forth from here. So we had to think, where do we want to make a pipeline? The code generation capabilities seem really solid generally, and so we did want to lean into that and try and create some code, because that is honestly the biggest bulk of what biostats does. We do a lot of code generation. So we had to think, where would be a good place to start? The data set, and so what we ended up on was doing data set specifications. So what that means is, in the world of pharma, we oftentimes describe the data set we want in a specification prior to making that data set. So the data set specification is the description of, in kind of text, more or less structured text, saying, I want these variables from these locations in this data set, which was a really great place, we felt like, to start, because it had all the context you really need. A perfect data set specification should have every bit of information that you need in order to then make the rest of the data set. So the AI Programmer project was born for us. We took this project and we wanted to hit the ground running and move quickly. This is a sort of, as we've all seen, Gen AI changes quite rapidly, and so we wanted to make sure we were doing small, agile projects that could easily be kind of tested out before we continued and went too far. So the first thing that we did is we had an initial experimentation. So in December of last year, we started to work with a contractor to test if the LLMs could read dataset specifications. So, but again, I said we wanted to do this fast, so we did some things first. First, we kept everything external. It was just much easier in terms of managing GSK systems and etc. if we just didn't bring it in-house quite yet. we wanted to see if it worked, and we didn't necessarily need to be using our internal specifications. The other thing we did is we used the OpenCDIS datasets and an external model. So we weren't using our internal specifications, we were using the ones from the CDISC pilot and also the datasets from that specification, which allowed everything to be done relatively quickly. The final thing is that we actually got all results in Python. We are generally an R shop here at GSK. We love R, but a lot of the people who are experts at dealing with LLMs and stuff are your more traditional Python-based data scientists. And so we figured it was just easier to start with Python and then we could go from there. So the general results looked kind of like this. You have a chunk of things that were successful, a chunk of things that were oof, and a decent sized chunk that just didn't work at all. When you see the success, a lot of it was really, really basic stuff that honestly you don't need an LLM to automate, doing things like pulling through the age column from the DM dataset. It's very straightforward, and you would have expected it to do it correctly. Things that it got mixed results on were things like when you talk about study ID as data visit 8 or things like that, where you're not giving a clear column and you're using more casual language to describe things. Or you also have cases where you say things, in this case, one of the flags should be equal to completed. And it's just written completed in prop case, which is a very normal way to write it. But actually, in a lot of these Atom datasets, everything is capitalized. And so the model didn't ask the right question here because it just didn't have enough background knowledge to be able to do this. So, and then the final thing that it oftentimes failed with is it would definitely fail anytime you had references to like the SAP, because as I said, this was just the OpenCDISC dataset or OpenCDISC specification. It wasn't perfect, and it definitely had places where there wasn't the information available for the model to work. But we felt that these results were quite promising, so we went forward. So we started to create a prototype in-house. It took us about 3 months to build a prototype, and we spent a lot of time gathering sample code and specifications, as well as experimenting with fine-tuning and trying to get it to write code for the Farmiverse, which is a kind of a pretty big, popular collaboration here in pharma that GSK contributes a lot to. So we definitely wanted to see if we could use that. And then we created a pretty simple pipeline that would take in the dataset specifications, convert it to a prompt, and then get out the code. And the results were mixed. It generally works, but also it didn't work perfectly, and it didn't work perfectly enough that we could really think about rolling it out. So we needed to do some rethinking. And this is where I have to be a little bit quiet about. I have not been granted the permission to say exactly what we're doing, but I can tell you that GSK is entering a new phase, and we are looking to take this kind of new phase that we're working on and apply it to live studies. We are going to change up to do a little bit more of a multi-stage prompting approach and then productionize that with pending some internal quality benchmarks, as well as making sure the programmers that we use this do have positive feedback. We'll think about rolling it out to more and more studies. So that's where we are today and our tomorrow. But there is a little bit of a caution here. We're not there yet. We haven't reached tomorrow. Tomorrow is still a little bit a ways away. And so for all the promising results we've seen, there's been disappointing ones. And I want to highlight our experiences and kind of some information that we've learned across the, like while doing these experiments. But you may have different experiences, and that's great. And so because we've not succeeded, I would take what we're saying with a bit of a grain of salt. But with that, let me share some of our experiences. So one of the first and most important considerations I feel like you should all think about it when you're trying to bring LLMs in or find LLM solutions is that you don't necessarily need a fancy automated system to save time. I know I've spent like, what, 10 minutes talking to you guys about all of this pipeline that we've maybe created, well, we've created and are still in the process of working on, but that only came after we got people using it in our larger community. And every day I go around the office in our little biostat section, I see people with the LLM chat we have up and open, and they're clearly using it, and people are clearly finding it's helping them with their job and doing their day-to-day work. So sometimes simple is best. And you can give people an opportunity to ask questions when you're rolling this out and kind of make sure you have guidance. But at the end of the day, what we found is that the best training is just the experience of using it, and kind of getting it into people's hands really allowed them to start using it. So we see time savings at GSK today with LLMs, even if we don't have a fancy pipeline. The next thing you need is, if you're considering a fancy pipeline, or even if you just want to bring it in-house, is you probably need a tech partnership. LLMs require oftentimes a whole different set of infrastructure than you potentially have built in the past, and you just need to make sure that as you're doing this, tech is very on board and that everyone's kind of singing from the same hymn sheet. Sometimes this is technology that's also new to tech, as well as it's going to be new to us. And so it means that everyone's learning together, and we kind of have to, A, give everyone grace around that, but B, make sure that everyone's on board to do that learning together, because there is learning to be done. Another thing that is going to be helpful here is to have some guides. The world of LLMs is quite different from the world of clinical programming, but also somewhat similar in the sense of there's a lot of jargon, and you'll hear things like RAGs or kind of multi-step prompting, all of these things thrown around, which don't feel like they mean a lot, but they mean something to someone. And that someone is probably someone with a lot of experience in LLMs. And so that is an important step. We found that sometimes trying to go it alone or trying to just experiment and see what happened resulted in us trying things that potentially we could have saved some time if we had just waited and kind of worked with someone who knew more information. And kind of on that note, one of the things that you may or may not have heard if you've talked to anyone who does LLMs is fine-tuning probably isn't the answer. And as someone who's attempted a little bit of fine-tuning, I think I'm gonna add to that pool of people who say fine-tuning probably isn't the answer. It is one of the easiest ways to kind of conceptually understand when we're talking about we need the model to learn a little bit more about CDISC standards. It does feel like fine-tuning is the right choice. And it might be the right choice for what you're doing, but especially when you're in a place like we are, where we're trying to support the transition to R, we don't actually have like reams and reams of data and lots of historic data of, or well, code in this case, the data is code, code written in R, because we're in the middle of transitioning. I mean, we have a lot by some standards, but from the standards of a large language model is really only a drop in the bucket. And so you don't oftentimes have enough examples to do successful fine tuning when you're trying to do this sort of kind of process. But that being said, it's going to potentially be a thing you need to consider. And I'm sure if you're working with somebody, they will also probably tell you fine tuning might not be the right choice for you. Another consideration that you have to think about when you're doing this is there's definitely trade-offs to be made when you're making a pipeline. So for instance, for us, we really went for a simple pipeline approach to begin with because we wanted it fast and we wanted it easy, I guess. So we basically took the whole specification and chucked it as a prompt at the model. And that was a very simple pipeline because you only had one thing going through. But there's downsides to that. It ends up being quite a complex prompt that you're asking it to do because you're asking it to go through the entire specification altogether. So there's definitely trade-offs, and where you using something like a multi-stage prompting approach, you have more complex pipeline, but you're allowed to have much easier and simpler prompts, which the model tends to be more successful with. But that's just, again, it's going to be your own personal choice depending on what you're doing. And the final little bit of kind of consideration and things to think about is that context is super important when you're dealing with these models. Dataset specifications, we think, are a great place to start a large language model journey because there's relatively little outside context needed. And the thing is that these generative AI models and stuff are really, a lot of them are built to write text, right? So you're writing text, and we don't actually make that many documents in biostats, or at least we don't at GSK. you write maybe your end of study CSR, you write a protocol, you write a SAP or some sort of document explaining what data sets you or what tables and listings and stuff you want, but that's about it. We don't have like reams and reams of documentation that we're making. And because of that, I think choosing where you want to start, it's totally open, but that can be you don't want to make a situation where you've require so much additional information that a user has to put in that you've not really saved time in creating a document because you need to put in too much information. Like, I don't know if for those who've used LLMs regularly, like I don't send every email I write through an LLM. It's just not worth it a lot of times. By the time I explain the context, especially if it's a long back and forth that has happened, to the LLM to then write me an email, I've saved zero time. Whereas sometimes I do use it for things like emails, especially if I'm writing an email maybe to like the Diversity Alliance or something like that, where I don't have a lot of backwards context that's required, and so it's easy for me to put it in as a prompt. But those are just things that we've learned so far and have some feelings about. Where are we thinking? I promised I'd talk a little bit about where are we thinking beyond tomorrow and how is this going to change kind of what clinical programming looks like, what everything is. And we think that one of the things we see is that there will be a bit of a change in jobs. I think people who today are primarily code writers might go to more code readers and reviewers. When you get the code out of LLMs, you do have to read through everything kind of line by line, which is not necessarily a skill we've historically cultivated in clinical programming. Um, Instead, relying on oftentimes kind of blind double programming rather than code review. So that code review skill will become more and more important, and it's definitely something worth working on if you've never really done it before. Another thing that's going to be important is prompt writing. And because we feel this is important, that's part of one of the reasons we push to get people to have access to the system today so that they could start working on that skill now. And so in the future, they'll have better ability to do that. Another thought about what does the future hold is I think LLMs put a really interesting question on the role of standards for the future. With automation being possible without necessarily a super strict standard through the use of these kind of LLMs, where do standards sit? How much of things should be standard? This is not a thing we have an answer for. It's just a thing we think about in terms of what we're doing in the future. But overall, LLMs have really helped GSK kind of, I think, move forward and accelerate their journey, even if we don't necessarily have a pipeline up and running now. Being able to have access to LLMs and in your day-to-day work can be really helpful as a tool to continue to learn open source languages and move from kind of historic languages. With that, that's all I have. Any questions, I think? Oh, I see something in the chat. Maybe. I so RN Pharma has done earlier this year a open AI day, which was really successful. But I don't know if there's another group that's doing kind of a pharma specific AI.
So we were just talking about this when the question came up backstage, and it's something that we as an organization that are in pharma could even think about helping to try and facilitate if there's interest within the community. Feel like it's something that's really gaining traction now, especially with all the talks we've had this week. So, and also after the Gen AI Day, so if there's interest within the community to set up like a monthly discussion type thing or more presentations, we could probably help facilitate that. So I'd say people in the community, if you're interested, start to reach out to us, and we'll build a little community together.
Clicking all the wrong buttons on Zoom today. Man, Zoom. Oh, goodness. I mean, it was a matter of trying to basically get as many examples as we possibly could. It was a lot of beg, borrowing, and stealing anyone's code who would let us have it. I think another thing we've done is GSK has gone to using GitHub as a tool, which has helped in terms of trying to pull examples to build from to deal with training data. But we have gone to also like that is one of the big problems with trying to do any sort of fine tuning as opposed to going with like a RAG or a multi-stage prompting or single shot prompting, because with single shot prompting you don't necessarily need to have quite as much historic training data to deal with, which has been like helpful.
I'll ask you some questions, but so how's your personal like use case with Gen AI going? Do you like using it for programming? Do you use it for the packages you build and maintain? Has it integrated into?
Yeah, I do. I think as um I think that the I tend to not use it for code as much as I do for like writing and documentation. But like personally, I'm incredibly dyslexic, and so like to some extent, it's like a dyslexic dream. I'm like, haha, I never have to write anything ever again. It's amazing. So that's really nice. But yeah, no, I do use it for code. I do find um it was really interesting Joe's talk on Monday, because I find like if you do some things, it does pull up historic stuff. Like anytime I do stuff with shiny modules, it uses like the old module style rather than the new module style, and then I'm always like, ah, foiled. Why have you been giving me this information? I don't want this.
Right.
So yeah, I would say I'm excited to use the thing that Joe recommended, that the new stuff from Posit. But yeah, I use it for I use it here and there. I think I use it the most when I'm honestly stuck. I'm not I'm not a person who tends to when I'm coding, I tend to code quite fluently, and then I sit and do a lot of thinking about like design and things like that. And so I'll do more chatting with it to like help me think through designs and problems like that. If
Yep.
that makes sense.
Got some things coming in the chat. Let me see what's popping up. Someone says, if you beg, borrow, steal, code innovation will be lost. Do you think so? I think I
Well,
put that quickly.
no. I think I'm well, it's mostly for doing training. When you're doing fine tuning, you need to have code, basically older code to do the fine tuning on, especially if you're trying to get it to use new packages or internal packages. Um, you basically to do that fine tuning work, you need to have examples of that code being used and kind of the basically you always are looking for pairs of stuff. So if you're taking in data set specifications as an input, you need the code that then is the output so that it can train on that. And that's
Someone says, I love this quote. I want AI to do my dishes and clean my house while I do creative work, not the other way around. And I think we saw that a lot at the Gen AI Day that we hosted back in September. It really seemed like the farmers wanted to find opportunities where the stuff that was, a little bit more heavy to do, that wasn't as innovative, pass it over to Gen AI. One thing in particular that was coming up was like updating documentation, writing tests. But I also like the idea of people using it for medical writing. Have those types of use cases popped up for you internally, you think, or have you seen stuff like that?
yeah, it's one of those things that we are thinking about. We're a relatively small team, so we're a combination of a relatively small team. There's like probably 10, 15 of us who are kind of doing this sort of work really. And we do a lot of, and so it's in the world of things we think about, but we're trying to get this particular use case off the ground and then potentially think about expanding.
Yeah. I've always think back to with the Pharmaverse examples that we talked about and built about a year or so ago.
Mm.
Now with so much of the R and Python code readily available and people creating all these nice examples, you could envision a way where people train and learn how to use these tools using systems that are available to give you instruction based on the code that's there versus some of the other stuff that maybe was tricky to access. Have you seen anything like that? I know Roche gave a talk on a bot that they created internally that was trained, I think, on some Pharmaverse packages and things like that.
Yeah, we haven't done that yet. But it's kind of in those like world of ideas that are floating around that are future potential ideas, once we get through our current ones.
Yeah. So, so someone said, are you utilizing code review of AI created code to replace your double validation process?
So, again, these are potential tomorrow things we are thinking about, but we're definitely not there because today all we're at is just basically kind of standard AI use, but internally. But like theoretically maybe is probably as much as we would potentially get to right now. That's what I can say.
What would be your favorite one if you had to pick the next one? Where do you see the most potential or opportunity?
Well, so oh, I don't know. I mean, so the idea is, I think I'm taking Kyle's words out of his mouth, but is that basically what we're doing, the pipeline that we're looking at today, Phil, we could theoretically say, oh, we could do a code review on that instead of doing a double validation. So rather than currently we do two blinded QC, right? Like you have two people who don't know what they're doing, who don't look at each other's code, do the code together like independently and then compare. But theoretically, you could do a code review on just what comes out of the AI. Um, and that is a potential you could, there's like, I think a lot of ways to slice and dice this. I think at the moment you have, because it's the most risk averse, which I think is the correct way to go. We have the maximum amount of effort. You have two people make the same stuff, and do that entirely independently. So if we're having LLMs kind of help those two people independently, that's a step that you could save some time for each of those two people. You could theoretically think about maybe being one person doing it all by hand and one version being just purely LLM created, all sorts of different ways. We are not we are not at a place where we're like looking at making decisions of this is how we're going to go and this is where we feel like is the right level of risk for us to hold. But there are so many options of how we could pull this in as a long-term process.
So Jared says, wouldn't that make it more secure given that you oftentimes find programmers who are not following the process exactly, and with the use of AI, at least one side is following every step?
Kind of. The thing about Gen AI is it doesn't always listen to rules really. Like there's a certain amount of it's gonna do what it's gonna do, and you can't 100% say, I am very confident that this will always do it exactly in this way. And so it kind of depends on, so yes, theoretically, maybe, but also Gen AI isn't like a deterministic automation. So deterministic automation, you'd be like, ah, they're definitely doing it right because we've determined they will do it right. But this is a little, because there's fuzziness around it, it has a little bit of fuzziness.
So following up on that, from a topic that was brought up yesterday, how do we ensure reproducibility when using AI tools? Like
Yeah,
that's
and I think
invalid.
so valid. And one of the things that I remember Joe talking about, sorry, I just keep talking about Joe's talk because I really liked it, was that it's really good to have these Gen AI tools in places where there's not one perfect answer. There's not necessarily one perfect answer of how you code an ADAE. And so I think the question of reproducibility, while important, as long as we keep the code that comes out of that model and like that's the official code, we're not necessarily trying to um always make the exact same ADA every time, at least for what we're doing right now at GSK.
Joe talked about using Shiny for data analysis and seeing the SQL and getting some down to that level. A colleague of ours, Winston, has done work on using Gen AI and Shiny to make Shiny apps. And it's interesting. I was recently prepping a paper and I was trying to create an example and I just couldn't find anything on GitHub or online that had anything like what I wanted. And I was impressed that Gen AI and Elmer and these tools were so easily available to make an example that was working. Have you seen it used internally to create things like Shiny apps or content for people? Let's say that's maybe not an open source program or somebody coming new to it that wants to create that type of content. Is that?
Yeah, I mean, to some extent, that's our primary use case today, is that we have really encouraged and tried to support basically our clinical programming, or well, really all of biostatistics, to use these sort of Gen AI tools to help adopt R, and move into the kind of open source and allow them to go into that. I mean, GSK, like many organizations, we have some goals about how much code will be written in R versus other languages by the next whatever year or 2 years. I don't even remember what the goals are, but because I write everything in R, so they're a little bit unrelated to me. um, but so we have really spent a lot of time with kind of study teams and the like, working with them, answering questions they have about using Gen AI and things like that, so they then do use it to kind of do exactly as what you describe, really.
So I've got a question here. It says, have you considered the benefits offered and the approach from the Google stable with their notebook LM beta, particularly with the references generated to allow for deeper checking? Have you seen
So we
notebook?
don't tend to use that at GSK. I think we have stuck to our, basically because we have an internalized GPT model, we just do everything through that. It to help reduce any risk of kind of data leakage or things like that. Because we just have a lot of sensitive stuff. We have not touched a lot of those sorts of things.
Yeah, yeah. Yeah, I haven't had a chance to play with it either, but it's been popping up quite a bit. Another question here is, do you think the public will trust data that's been validated using AI tools, or find trust in these tools that will be pivotal in drug approvals going forward? Yeah, but
Yeah, I mean, we're pretty firm believer to have a human in the loop. So we kind of do a lot of, so our goal really would be to allow from the sense of doing automation based off of data set specification, is to allow a clinical programmer to pick up that code, look at it, review it, make sure they're happy with it, and then take it and run it and act it. So if it's their own code, like, I mean, like the code you get off Stack Exchange, like, yeah, Stack Overflow. There we go. Can't even say things today. Like, there's a lot of code that I will fully admit I have personally taken, and I've been like, put that in my code. I'm like, oh, that works. That's good. Like, I've reviewed it. But I definitely did not write every word of that thing. And so it's trying to get something like that. We don't necessarily, we would always keep a human in the loop, because we do think it is important to not allow stuff that's going to like the FDA. It's just so too important to not have some oversight.